I love the music that starts up in this game. Hey guys, Rorius here. Welcome to Human Resource Machine, or welcome back, I should say. This is like episode 4, I think. So we've been playing it for a little while now. Okay, so while I was editing one of the previous episodes, I saw how I could make this one better. This maximization room better. So, what the hell was it? Oh god, what was it? Okay, I just looked back at the episode that I recorded before. Apparently it's the F-Zero? When I was looking at it during editing, you know, I was paying attention to what I was doing, so it makes sense. Let's just see if I remove the F-Zero. What that does. So it'll do an extra command, it'll do the extra add. So it might not be as efficient in the executions. Okay, let's just check. We'll speed through it because we've already done this before. Let's see if it still outputs the same. It does, and it's using one less command, so it completes that one. And it still is the speed challenge efficient level. Frickin' sweet. Oh, whoops. Yeah, went back and got it. I did not see how I could do this better. Or these. I think I might have seen one way I could have done these a little bit better, but I hadn't tried it, you know. So I can't be sure that either of those will be good. 3 sort, I'm not even touching anymore. Let's go to 0 terminated sum. That wording, those words sound like I should know them. I feel like I've heard those words before and I know the meaning, but it does not come to my brain right now. Yes, we believe in educating our employees on the job here. Do you know what a 0 terminated string is? Yes, it's a very old technique and we don't expect you to know. So you may ask me about it if you like. Or you may ask an external source. Whatever helps you get the job done. Okay. The inbox is filled with 0 terminated strings. What's that? Ask me, your boss. Add together all the numbers in each string. When you reach the end of a string marked by a 0, put your sum in the outbox. Okay, I don't remember what that is. 0 terminated sum. Let's have a look. Oh, okay. So, of course, 0 terminated. Of course, so the first string in this... So, yeah, we're working with like an array sort of system. But what we're doing is we're adding together everything within the array. Oh god. So our array is terminated by the 0. So this first array is 9 and 7. So you just need to add 9, then add 7, then you get the 0. So you throw the 0 out, grab whatever is the result of 9 and 7, and throw it in the outbox. And then the same will go for, you go 6, and then -1, then 6, and then whatever that is into the outbox. Okay, this should be fine. What I'll do is I'll get a little loop going, and then I'll get a loop going around the inbox part, and then I'll get a thing that jumps out of the loop to outbox, and then jumps back into the loop at the end. So, yeah, inbox. Wait, how can I do this? Inbox, copy to 0. Okay, no, I'm gonna have to do a copy from, I'm gonna mark this as 0. Copy from 0, and copy that to the 0 position, which I'll just call box, because it's the one that we're going to use for everything. Copy it to the box, then, and that's at the start of each loop. Then inbox, add to box, or add from box, and then copy to 0, and then loop, basically. But before we loop, check if negative. If it is negative, jump out of the loop. Sorry, not if negative, if 0. If it's 0, jump out of the box, out of the loop, sorry. Copy from box and outbox. Oh, whoops, in here, like that. And then jump back to the start. That should be it. I believe that's it. Nice and straightforward. So yeah, we copy the 0 over it first, so that we can just have a value here, so we can start with adding to 0, basically. And then we'll, yeah, there we go. And then we grab the 0, it's like, oh, that's the end, so... Wait, what? Oh. I think I, put the F-Zero. Check in the wrong place, my bad. Yeah, there we are. There we are. that was dumb of me. Yeah, so it adds the 7 and the 5 together, finds the 0, copies the 12 over to there, resets, and then does the next one. Yeah, it'll copy and end each string at 0. Yeah, perfect. Yeah. Ah, speed challenge failed. Oh man. How do we get the speed challenge up? I might have to add a whole lot more commands. I think I'm probably... This is a statement that's probably not true. I was gonna say I'm probably better at getting the shortest commands than I am at getting the shortest rotations, but that's probably not true. There are several times where I got the shortest executions, I should say, because I made the thing just a mess of commands. Okay, so I think probably where we're going to have places where we can reduce the cost is if instead of having this like this, if I just have an inbox and a copy to there instead, and another check F0 back to here. Oh wait, no, F0 jump to here. Oh, but actually, no, if this is the first one, if the very first one you pick up is 0, and there's, so therefore there's nothing, the string is 0, then outbox the 0 that you've got. Yeah. Yeah, so we've done this in a few more commands than necessary, but that should be way more efficient already. Because I've removed the reset phase, and I've just worked around the reset phase. So there's no more, I don't even use the 0 anymore. So yeah. Hopefully this will still work. So this is an example here where it will be tested. This will be tested. Okay, it just outputs straight away. Wonderful. Perfect. This should be way more efficient immediately. Yeah, perfect. Yeah. See, I know my stuff. People are giving me sass in the comments about being like not able to do some of them. Oh god, my hair is doing this again. I'm not stupid. The littlest number. To reduce our carbon footprint, management is requesting the smallest numbers only. This is a public relations exercise. The results are going straight to the landfill. Ah. The littlest number. For each 0 terminated string in the inbox, send to the outbox only the smallest number you've seen in that string. You will never be given an empty string. Reset. Okay, so we don't have to worry about empty strings. Reset and repeat for each string. Okay, so we get like 7, 10, and 2, and we've got to find the smallest number. Oh, god damn it. This is just a min-max. We've already done this, but we did it for the biggest number first. And I sucked at that one. Except we're only sending out the smallest number, so it's way easier, actually. We're not sending them out in order, we're just sending out the smallest number. I should stop biting my lip. I keep biting my lip. Okay, let's just start doing stuff. That's how I usually start my coding projects. Just start writing shit. Fix it later, you know? Okay, once again, we'll call this the box, because this is where we're going to store everything. Okay. Inbox to the box, straight away. Inbox again. Sub from box. So if box is... So if it becomes negative, if negative, that's good. We want to keep going. Otherwise, just jump back to here. If it is negative, add it back onto box, and then copy to box. And then loop back to here. Otherwise, oh, also one last thing: if it is 0, if you inbox and it's 0, then let's jump up to here. Copy from. No wait. If the item is 0, yeah, copy from box and outbox. I'll put a little jump here again. Okay. This doesn't look as efficient as it could probably be in terms of numbers. But I think that's gonna work. I think that's gonna work. Let's have a look. Okay. We got 7, we got 10, so it's useless. 7's still better. 2 is better than 7, so it adds back on, copies it to box. Yeah, there we are. It's 0, so output that. Yeah, perfect. Yeah, only using one slot on the floor. Perfect. Yay! First try. So it was the most efficient. See, I'm okay at writing. I swear, a cumulative countdown, is it? What's the purpose of this assignment? I think it's something about calculating the volume beneath staircases. We have to put the intern somewhere. Oh my god. For each thing in the inbox, outbox the sum of itself plus all numbers down to 0. Right, so we're doing it an exclamation mark, basically. Or what's it called? What's that thing in maths called? Editing Rory will put it on the screen. It's basically where you have put a number and then an exclamation mark after it. It's basically that number plus the number -1 plus the number -1 plus the number -1 down to 0. So yeah, inbox is 3, outbox should be 6 because 3 plus 2 plus 1 equals 6. Yep. There's some I think I'm gonna need 2 boxes for. So I need the num. This is a real great variable names. Num and then res. Yeah, because what I need is I need an inbox. Copy it to num, then also copy it to result, then bump, no not bump plus, bump minus num, then copy from res and add num, and then copy that to res. Part of me hates that bumping numbers automatically adds them to your hand. Some part of me in previous previous puzzles, having the bump add to your hand was like great. That was perfect, exactly what I wanted. But there are so many instances where I want a bump that doesn't affect your hand. Because I could do this real easy if I could just bump it without affecting my hand. Straight away, I'm gonna do an F0. Just go no, outbox, and then. So wait. We'll do this whole thing again. F0, immediately outbox, and then inbox again. Copy to num, copy to res. Pop num. If num is now 0, then copy from num. Sorry, copy from res. And then outbox. And then we need one more loop here. Jump to here. Copy to res. Bump num. Yeah, okay, I think this is it. I think this is the loop here. I think we could have done this more efficiently if I got rid of this 0 check initially. I can reduce the number of commands, but then it'll increase executions. So let's try this. Let's copy it to both of those. Bump that one down. Grab that again, and then add it. Copy that to res. Bump down again. Grab that. Add it to res. Bump down again. Copy that. Add it to res. And then this is where it all comes down to it. Sees it 0. Grabs the 10. Outputs. There we go. Okay, perfect. And then it'll happen again. Yeah, perfect. Just immediately output the 0. That should be 6. Perfect. Freaking sweet. Yeah, I was gonna say speed challenge won't be the same because what I can do is if I remove the. Oh, but wait. No, wait. Did I get the? Wait. Did I get the other way round than I thought I would? I think I got the reverse thing that I was expecting. Yeah, what the hell? I got the size but not the speed. I intentionally put extra commands in to make it faster. Thinking that... Because I could make it smaller. I could make this smaller. If I remove the 0 check initially, I can make it 1... See, if I remove the 0 check... Oh wait, I shouldn't do that. I should copy it. Copy. Okay. Paste it in here. If I remove the 0 check, it still works, I believe. But it will, No, it doesn't. No, that's necessary. No, it doesn't. Ah, I see. So no, you have to. Alright, well, I'll clear that. Well, shit, how do I make this more efficient? Yeah, no, I didn't realize. I forgot that. No, that's very necessary. That's why that is why the number is what it is. Yeah, I honestly don't know how I'd make this more efficient. And I don't know if I want to spend the time to figure that out. So we'll leave it. We'll leave that one. I'm sure Editing Roy will probably see something with that, though, because I think that actually wouldn't be very hard to get. The efficiency thing would actually be quite easy on that one. Let's go to Midnight Petroleum. I'm curious as to what is happening in this world. Rolling blackouts, robot army. I think the third one we got was like sitting at a beach. No big deal. What the? That is one massive moon. It's not a moon. Is it maybe one of the robot army? Robots? Is that why there was a rolling blackout? Because the robots were like consuming all the power from the city? Oh, I forgot to mention it earlier. I had this like crazy red mark. Career milestone 4. Yeah. I had this crazy red mark on my below my eye. I don't know why it was there. Don't know what caused it. But whatever the case. Let's see how far we can get. We'll do a few more. We'll do 2 or 3 more into this. I don't think we'll get to Where's Carol. But we'll try and get to a string reverse if possible. Storage floor. Oh man, I'm getting old. Yeah, that's why, like, in the previous section, my character's hair was, like, thinning in the middle. Now he's going white. Big changes are coming. But I see you already know that. Yes, you can now access slots on the floor indirectly. What does that mean? You will see. It's going to change everything. Okay. Ooh, what have we got here? Imagine each thing in the inbox is an address, and each address refers to a tile 0 through 9 on the floor. Your task? For each address in the inbox, pick up the letter at that address and outbox it. Oh! Congratulations, you can now access tiles on the floor indirectly. Observe this example to see how it works, compared to what you've been doing so far. Copy from 12, and then copy from 12. Copy from 12, we'll grab the 8. I know. But wait, copy... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So wait. Oh, I'm confused. Get rid of that copy from 12. So wait, when I'm selecting this... So if I say pick up from 8 with the brackets instead, you can't indirect to a tile with a letter like Y. Only numbers allowed. I don't understand what it's trying to say. Oh, no, I get it. Okay. Okay, I see. No, I totally get it. Alright. So, I was like, what is happening here? What we're doing is, essentially, with this copy from, what we're doing is we're using an address, information and an address, to grab from a different address. So this is storing, basically this index, this integer, is storing, this integer is basically another address. So when we go to pick from 12, what we're actually doing is we're saying, whatever number's at 12, pick from the box with that number. So when we pull in 2, when we pull 2 onto the floor, we can then grab from the index of 2 or the address of 2, which will go and grab A. So this will equal, this output here, this thing will equal A, L, N, N, N. So yeah, let's do that. Let's inbox. Copy 2. Oh. You can copy 2 with this as well. Copy to 10. We'll call this once again the box, because it's the only one we're gonna use. Box. So copy to box, and then copy from box, like that. Yeah. It's it's weird because we're not gonna see what it is until it happens. And outbox. And then jump. That's it. It should be that simple. Unfortunately, it looks like we have to use an address on the floor. We can't use what's in our hand as a copy from location. So we're gonna have to do the copy to, then the copy from. And that's it. So yeah, he'll take in the 2. He'll copy from A, and outbox. Next one, he should grab the 7, copy from L, outbox. And then the rest is 0, so they're all in. In. Aln. Okay. So yeah, they gave us a really simple one to get you familiar with how that works. String storage floor. Special covert assignment. Management is requesting strings from the floor. Let's just process the strings, and not read or discuss what they say. It would be impolite to read messages intended for someone else. And forbidden. Okay, everything in the inbox is an address of a tile on the floor. For each address provided in the inbox, outbox a requested item from the floor, and all following items on the floor until you reach 0. Oh. All following items. Get, th, tar, awake, is, and then xxx. Inbox, copy to 24, which once again we'll call the box. Then we copy from box like that. Outbox, and then bump down. Box. No, bump up. Box. No, not box. That box. There we go. Okay. And then jump. Do an F0 check. Then jump back to this. I think that's it? I think that's what it's wanting. This is super fascinating. This is such a different... Yeah, this is very different from anything we've been doing. So it'll copy from the 4, which is a T. Outputs. Bumps it up, which is now 5. Takes the 5, outboxes it. Then it goes to the 6, which is 0, so it goes to the next number. I was gonna read what it says. The tar get XXX. Is awake. I'm assuming it's going to do that whole thing. Let's not read it anymore. Let's just speed through it. This is looking promising, though. It seems to function exactly how we want it to. Yay! 203 is the minimum, whereas, you know, the one of the lowest you can get. The lowest required, at least. That's fascinating. Well, yeah. These have been pretty easy, honestly. Just leading us into what I'm assuming is going to be some really freaking hard stuff coming up. Oh, I'm kind of nervous for what's up ahead. String reverse. Oh. Hola. It's hello. How are you today? Okay, now seriously. Okay. For each 0, terminate the string in the inbox. Reverse it and put the result in the outbox. Oh no. Oh no. Okay. Inbox, copy to here. Bump up this. And then loop. If 0... Oh, wait, no, not copy to 0. Copy to this, like that. Bump it up. And then jump. Or do I copy it away from it? So what I might need to do is I might... No, you know what? What I'll do is I won't do that. I won't make a copy of this. What I'll do is I will, at the end of the loop, I will copy from whatever's there, sub whatever's there, and then copy to whatever's there. That is not more efficient. I don't think that's more efficient. I think that's worse. Okay. So, right off the bat, copy from here, copy to here, and then bump this one up instead. Call this the iterator, and this one's 0. Oh, what the? Oh, right, yeah. I was like, why am I copying to 0? No, it's copying to whatever value is in... Actually, it should be this one. It should be whatever value is in the iterator. There we are. If you end up with 0, then what you gotta do is you have another loop. Copy from this, like that. Basically the reverse of this. Copy from that, outbox, and then bump down the iterator. Oh, whoops, it's not copy from 0, it's copy from this one, I. Then bump down I, and repeat? Yeah, then loop this. But then, if negative, at the end here, if you end up with -1, then you reset. Yeah, and you do the copy from 0, copy to thing. Oh, whoops, this is not the right place. There. Yeah. Okay, we've got 2 loops here. 12 commands total. I think that's about as good as I can do. Let's just see it functioning. So, immediately get the iterator going. I don't know how many of these is going to be here. This is actually way better, being able to reference slots on the floor dynamically like this. Oh, I see. Okay, no, wait. If it's 0, you've got to immediately bump down the iterator. Because, yeah, my bad. I feel like I could probably write this slightly differently and it would be more efficient. You know what? I will. I will immediately. I'm going to bump up the iterator, so we're not actually going to use 0, I don't think. And instead of if negative, reset, we'll make it if 0, reset. Like that. Yeah. Okay, I think this is good. I think this is good. Yeah. Let's try that. So, yep. Copies the iterator over. Or immediately bumps it up. Wait, have I done this? This is probably wrong again. Yeah, this still doesn't work, does it? I'm dumb. Yeah. Okay, no, what I was doing before was the right thing to do. Undo. Oh, stop. Undo. Undo. There we go. Okay, so we immediately, once we get that 0, we immediately bump down the iterator instead, and then start working from, yeah, one iteration backwards. So, go like that, bump it up to 3, but then it's like, oh, okay, bump that down, grab that, bump that down, grab that, bump that down, grab that, and then, yep, back to a new word. Yeah, cool. 1 byte. Who? Okay, that's not going to be the most efficient. Especially for this. Oh no, I got the... I keep thinking it's the other way around. I'm like, okay, I can definitely make, bring the efficiency, this efficiency better. And this... 11. We're 2 off. A command to be able to reset something or change something to 0 automatically, or to put a 0 in a place, would be so invaluable. Efficiency increased massively. Because, like, half of the stuff, my problem is I'm trying to do a copy from 0, copy it to I sort of thing. If I could just remove that and just reset it to 0, I could just, you know, only use one of these 2 slots. Because I could just immediately reset a number to 0. That'd be so useful. Well, I reduced one of them. I got rid of one. I think it'll still work. Let's just see. Let's just see if that still works. I think it might even be slightly more efficient as well. I think it was like 119 before. No, it's actually less efficient. That's fascinating. That's fascinating. Yeah, I need to get one less command further. I'm sure it's a structure thing. If I looked for a while, I'd probably be able to find a place where I could remove one of the jumps. So I think everything else is pretty well necessary. Even then, I can't see how I would do it differently. No jump feels like it's being used for a purpose that's not necessary. No, I don't see how I could remove any commands. Oh well. Shall we do this last one? Yeah, we'll do inventory report and we'll get to this new copy. Inventory check. Accounting verification. Surprise audit. These are a few of my favorite things. So let's get started. Alright. For each thing in the inbox, send to the outbox the total number of matching items on the floor. Oh. Okay. I see. Wait, how the hell do I compare them? For each thing in the inbox, send to the outbox the total number of matching items on the floor. So yeah, if I pick up C, it'll see there's 2 different C's here. So that'll be 2. I'd be outboxing 2? How do I compare them? We're dealing with letters, not numbers. Okay, let's just see what happens if I bump. You can't bump with a letter, what would that even mean? Yeah. What about sub? What about inbox and then sub from the letter? That doesn't mean anything either. Oh no, it equals 0. Okay. Okay, well I'm gonna copy from 0, copy it to this spot here. Call this 0. Call this one here, the iterator. Okay, so yeah, if you sub from a letter, if it's the same letter, it'll be 0. Okay, okay. They didn't specify that. I even looked at this. It doesn't say anything about letters in here. Alright, alright. So we inbox, and then we sub from the iterator. Whatever the iterator is pointing at. If it is 0, I will do something specific. If it's not, copy from that. No, wait. Okay, wait, no, I'm gonna have to, when I inbox, I'm going to have to copy to this, which will be, which I will refer to as the, template. Template. So, inbox, copy to template, then sub from the iterator. If it's not, if it's 0, then, we're gonna have to get another iterator. Let's use 17 as J, secondary iterator. If it is 0, that means I'm gonna have to also do a copy to, copy to the iterator and copy to this iterator as well. So they're all 0. If it is 0, bump up the J iterator, and then copy from the template. Bump up the J iterator, bump up the I iterator, Okay, what I might just do is I might just... No, not bump. What am I doing? Jump. Jump down here, and then jump down here. This won't be the best system for it. Now, how do I stop it when it reaches the end? Shit. How do I stop it once it reaches the end? Oh, actually, no, what I should do... Instead of having the template... Wait, no, do I need the template? No, I still need the template. But instead of having... Instead of grabbing the template... No, what I should do is I should... copy from the iterator position and compare that to the template. Sub from the template. Yeah. Yeah, that way I've always got the... Yeah, that should work. That should be better. If it's 0, bump up J and I. If it's not, just bump up I. And then, yeah, I can remove that one. I can remove that part there. And then, because I'm copying from the iterator point, I can do an F0. If it reaches this 0, the 0 can be used for 2 functions in this. If it's 0, then start again. Except it's going to start there because, yeah, because it already has I in its hands. So I can just immediately copy that 0 to I and J. Oh, wait, no. Shit. Almost missed that. No, because I need to output J. Okay, no. Let's do... it doesn't make it any more efficient doing that. Let's jump down here if it's 0. If it jump down here, copy from the J. And then outbox and jump back to the start. Yeah, I could do this better, but we'll screw. We'll just test to see if that works. So it does a reset, grabs from the inbox, puts it into template, checks it against that, bump up I. Oh wait, no. Oh no, it is working. Good. Okay. And these will check through. Once it reaches B, it'll be the same. Oh, what? Oh no, I'm doing X. So it'll go here. It's the same. So bump up the J. Yeah. It'll get a third one. And then it'll get 3. Then it'll check against the rest of them. And then it'll, output the 3. Cool. So it's checking how many C's. There should be 2 in the whole string. Yeah. B, there should be 1, 2, 3, 4, 5 B's. Oh no, it's checking A, my bad. 1, 2, 3, 4 A's. Now it's doing B's. So there should be 5 of these. Four and 5. There we go. Perfect. Yeah, I was gonna say, like, I'm glad I got the size one because I was gonna say this is the most. This is the like. This is one of the longest stepped programs I've done in this game. Do I struggle to make it more efficient? Problem is, because I need to have some sort of Terminator, in this case the 0 here, I can't do it the other way round, which I think is slightly more efficient. Yeah, we'll leave that there. We'll leave that there. Cool. It's interesting how it flip-flops back and forth between me doing the best in the speed and then the best in the efficiency. That's fascinating. Whatever the case, where's Carol? We'll watch this and we'll call it an episode. Oh, Carol was the woman who was here at night, wasn't she?
Hey, where's Carol? Oh my god. This coffee is amazing.
Oh god, what the hell?
Back to work, ladies.
Breaking. Previous reports of machine army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
Okay. Well, that's career milestone 5. I would say that we could do this in one episode, but that's probably going to be one long episode, so no guarantees. I might only be able to get like 4 of them done, and then the last lot. So yeah, 1 to 2 more episodes of this. Actually, yeah, it'll be like 4 and 4, probably. These are going to be so hard. I'm so not looking forward to that. Oh, this is actually a really good teaching tool. I think this actually should be used in some capacity in like schools or university to help teach people how to do sort of the logic of very, very linear programming. Because that's what we're working with. We're working with a very linear system, which is what all those old like assembly languages are. They're very, very linear programming languages. We, at university, went straight to object-oriented programming, which is much more abstract. And so that's why I'm not the greatest at linear programming, because I'm so used to having object-oriented programming, which is essentially where you can have bits of code in different areas functioning separately from each other instead of trying to like stumble over yourself in linear. There are advantages to both of those systems, but yeah, my brain works object-orientedly. So trying to work with like these older systems that are much more linear is very hard for my brain. I'd like to see a game like this, but with like more modern object-oriented style. That'd be really fascinating. Fascinating to see. Well, whatever the case, if you like what you saw, hit like. If you want to see more from me, then subscribe. Thank you so much for watching, and as always,